200 years ago, if you looked down at Earth from orbit, you would see a quiet world. Vast, unbroken forests covered the continents, and the human footprint was barely a smudge against the natural landscape. That quiet ended when we learned how to burn compressed ancient sunlight. The introduction of the coal-powered steam engine gave human beings a mechanical muscle that never tired. We used that new strength to carve straight lines through nature. Instead of navigating around mountains or deep valleys, work crews blasted straight through them, laying down thousands of miles of iron and wood to connect distant towns. Those localized bursts of heavy industry allowed human populations to grow rapidly, but they also initiated a slow, continuous transfer of stored carbon out of the ground and up into the sky. We simply lacked the vantage point to see the atmospheric toll adding up. By the start of the 20th century, the pace of land transformation accelerated. Mechanized plows turned wilderness into millions of acres of agriculture, while electric grids illuminated rapidly expanding cities. That same industrial capacity eventually turned toward mass destruction. During the total war of the 1940s, factories churned out bombers and artillery around the clock, leaving entire urban centers completely leveled. Rebuilding a fractured globe required immense amounts of concrete, steel, and fuel. For decades following the war, global manufacturing expanded continuously everywhere, venting millions of tons of exhaust straight upward. We had built the machinery required to flatten mountains and level cities, but we were still treating the sky like an infinite void that could absorb anything we threw into it without consequence. In 1969, humanity reached the surface of another world and pointed its cameras back toward home. Seeing Earth from the moon revealed that our atmosphere isn't an endless sky, but a thin, glowing shell protecting a finite world. By the 1980s, that single perspective was replaced by a network of satellites. We moved from occasional photographs to collecting continuous hard data on the planet's vital signs. The sensors captured a stark reality. They mapped a sprawling network of concrete, asphalt, and traffic that was rapidly expanding across every habitable continent. As our orbital technology matured enough to let us monitor the planet as a single organism, the data confirmed that our rapid, interconnected growth was suffocating it. Solar radiation warming the surface, but returning heat hits a thickening layer of industrial gases and cannot escape. At the North Pole, a vicious feedback loop begins. Shrinking white ice exposes dark ocean water, absorbing more heat and accelerating the cycle. We don't rely purely on models. Decades of orbital and ground observations document massive, ancient glaciers fracturing and retreating into the ocean year after year. Losing polar ice removes Earth's primary temperature regulator. Without it, the excess heat begins to tear at the mechanics of the atmosphere itself. This map visualizes global atmospheric currents. A warming Arctic causes these once smooth jet streams to buckle and stall, trapping weather systems underneath. Over land, stationary heat waves bake the surface, fueling massive wildfires. Over oceans, superheated water acts like a battery, spinning up rapidly intensifying cyclones. The destructive weather we see today is exactly what physics dictates. It is the precise mechanical output of an atmosphere overcharged by 200 years of excess thermal energy. In early 2020, human industry ground to a sudden halt. The global response to the pandemic inadvertently set off a massive, rapid atmospheric experiment. With flights grounded and urban commutes suspended, satellites registered a massive drop in nitrogen dioxide within weeks. Smog cleared, People in dense urban centers looked up and saw clear blue skies for the first time in years. That brief clearing proved that Earth's atmospheric chemistry reacts immediately to our behavior. The momentum of climate change is entirely dependent on our continuous input. The mechanical ingenuity that built the crisis is now being deployed to mitigate it. Massive fields of silicon panels and turbines are capturing energy directly from the sun and wind, bypassing the need to burn carbon. The orbital perspective that first showed us our fragile reality is now guiding this transition. Satellites act as our planetary diagnostic tools, tracking emissions and measuring reforestation in real time. Humanity has spent 2 centuries proving we have the power to dismantle Earth's climate. Today, the orbital view proves we also have the data required to begin making